Want to get faster at 2x2 and average sub 4? CLL is a two-step advanced method for 2x2 where you solve a layer at the bottom and then solve the corners of the last layer to solve the cube. It's important that you have a solve face for this method because otherwise the algorithms shown in this video will not work. I'll do some example solves at the end of the video to show how this method can be applied to your solves. But first, you need to learn 42 CLL algorithms, but you should already know 9 of them if you learned the Ortega method. They're broken up into 7 subsets and are quite easy to learn. For each case, we'll go over how to recognize it and then execute it. Starting off with the Sune subset, we'll need to know where the opposite colors are on the top layer and the color of this piece to recognize each of the 6 cases. If we have opposites diagonal from each other on the top layer, and this piece matches this piece, this is just your standard Ortega algorithm. If we have diagonals opposite from each other on the top layer, but this time this piece is opposite of this piece, you'll do a U prime pre-move to hold it like this, and then do this with my ring. If we have opposites horizontally and this piece matches this piece, you'll do this. Again, if we have opposites horizontally on the top layer, but this time this piece is opposite of this piece, you'll do this instead. If we have opposites on the top layer vertically this time, and this piece matches this piece, we'll do this. Opposites vertically on the top layer. This time, this piece is opposite of this piece. We'll do this. For the Anti-Sune subset, we'll need to know where the opposite colors live on the top layer and the color of this piece, as well as the non-opposite color on the top layer. So for example, in this case, this is the non-opposite color on the top layer. And we'll use that to recognize the 6 cases. So for this one, opposites diagonal from each other, and this piece matches this piece. We'll do this. Opposite colors diagonal from each other, but this time this piece is opposite of this piece. And so if this is the case, we'll do a U2 pre-move to set it up like this, and then do this algorithm. Opposite colors horizontally, and then now this piece is opposite of this piece. And so if this is the case, we'll do a U2 pre-move and just do the lefty version of this Sune algorithm. Again, opposite colors horizontally, but this time this piece matches this piece. And so we'll do this. This time, opposites vertically, and this piece matches this piece. And so if this is the case, we'll do a U2 pre-move and just do the righty version of this Sune algorithm. Again, opposites vertically, but this time this piece is opposite of this piece. And so if this is the case, we'll do this. Next up, we'll do the H subset. This one only has 4 cases, and we'll recognize them by seeing how many bars are on the top layer, and how the headlights are attached to the bars. So for this one, we have 2 bars on the top layer, and on one pair of headlights, we have opposite colors attached to them. This is just your standard Ortega algorithm. Same thing as before, 2 bars on the top layer, but this time one pair of headlights have the same color attached to those headlights. So you can think of this as horizontal bars. And so if this is the case, this is just F, triple sexy, F prime. This time we have 1 bar on the top layer and 1 pair of headlights have the same color attached to those headlights. So if this is the case, you'll hold it such that the bar is on the right on the top layer and do this. Again, we have 1 bar on the top layer, but this time when we have 1 pair of headlights facing us, this bar is on the right. And so if this is the case, we want to hold it such that this bar is closest towards us, and then do this. For the pi subset, we'll look at how the top colors are oriented, holding it from this position with the headlights pointing to the left. And we'll do that for each of the 6 cases. So for this one, holding it in this position, if we have a bar on the right and opposites on the left, we'll just do the standard Ortega algorithm. This time, if we have the bar on the left and opposites on the right, we do a U prime pre-move and do this. Now if we have 2 bars on top, we'll do this. If we have 2 opposite pairs on top, almost like a checkerboard pattern, we'll do a U prime pre-move and do this. If we have 2 adjacent bars here and here, so these 2 are adjacent and these 2 are adjacent, and the same colors on the top go from bottom left to top right, we'll hold it here and do this. So same thing as before, but this time the 2 same colors go from top left to bottom right. We'll do a U2 and just do the lefty version of the algorithm from before. Now for the U subset, we need to look at these colors and these colors. And for 2 out of the 6 we need to recognize, we'll also need to look at this piece's color. If you have a bar on the top layer and opposites here, this is just your Ortega algorithm. This time if we have opposites on the top layer and a bar here, we'll do a U prime pre-move and do this algorithm. If we have a bar here and a bar here, we'll do this. If we have opposites here and opposites here as well, we'll we'll do a U pre-move and do this algorithm. This time, if we have adjacent colors here and adjacent colors here, and this color matches this color, we'll do a U pre-move and do this. Again, adjacent colors here, but this time, this color is opposites of this color. We'll do a U pre-move for this one as well, and do this algorithm. For the L subset, we'll recognize the 6 cases by determining if the unsolved colors on the top layer are opposites, the same, or adjacent, and we'll use this piece as well to recognize the cases. So for this one, if the top colors are opposites and this piece is the same as this piece, we'll do this. So just the Ortega algorithm. This time we have opposites on the top layer, and this piece does not match this piece. And so if that's the case, we'll do this. So now we have the same colors on the top layer, and this piece is opposites of this piece. And so we'll do this. Again, same colors on the top layer, but this time this piece does not match this piece. And so if this is the case, we'll do a U2 pre-move to set it up like this, and then do this algorithm. Now for this one, the 2 colors on the top layer are neither the same nor opposites. So in other words, these colors are adjacent, and if this piece matches this piece, we'll do this. Again, these 2 colors are adjacent, but this time this piece is opposites of this piece. And so for this one, we'll do a U2 pre-move, hold it like this, and then do this algorithm. Lastly, for the T subset, we need to look at the colors of this bar and this bar. And kind of like last time, we'll need to look at another piece's color as well for 2 out of the 6 cases here in this set. So for this case, we have adjacent colors here and adjacent colors here. And when we hold it in its position with the solved colors on the right, this piece's color matches this piece. And so this is just your Ortega algorithm. Similarly, we have adjacent colors here and adjacent colors here, but this time this color does not match this color, it's opposites. So in this case, we just do a U2 so that these 2 colors match, and we'll just do the lefty version of the Ortega algorithm. If this bar has opposites and this bar has opposites, we'll do a U as a pre-move to hold it like this, and we'll do the algorithm. If this bar has same colors and this bar has opposites, we want to do a U2 to hold it like this, and then do the algorithm. If this bar has opposites and this bar has the same colors, we want to do a U and then do this algorithm. And when this bar has the same colors and this bar has the same colors, we want to do U and then do this. In some cases, as you're solving your layer, you might have all the colors on the top layer oriented. So in this case, this would just be either your T or J perm or your Y perm, depending on the case, just like in Ortega. So in this case, this is our T or J perm and our Y perm. And of course, as you're solving your layer, and you see that the whole top layer has been solved, you've solved the cube and skipped the CLL step entirely. Let's do a couple of CLL example solves together to get some practice on using this method. So here's the first scramble. When you're looking at a scramble and intend to use CLL, you want to try to find pieces around the cube that are already pre-solved. So what that means is that we have a yellow bar, a white bar, and these orange bars. But what these colors have in common is that these bars are not pre-solved. So what that means is, for example, we take yellow. When we pair them up together like this, these two colors are not the same. And then same with white. So white bar, these two colors are not the same. And then same across this orange 3/4 of a layer here. So these colors not the same, these colors not the same. So we're going to tend to ignore those colors and try to find other colors around the cube. For example, like this red and blue bar. So note that I said red and blue bar because these pieces are solved, right? So red bar, same colors, blue bar, same colors. So we have two options that we can choose out of this bar. So let's start with red. So the remaining pieces are here and here. They're already set up nicely so that we can just pair them up like this and bring them down. But as you can see, this is not a solved face. And so CLL wouldn't work for this layer. If you want to get more advanced using 2x2, there's another algorithm set called EG1 where you can make your layer like this with an adjacent swap. So a bar and then adjacent swap here. But since this is a CLL video, I'm not going to do that. So let's look at blue and we'll notice that the two remaining pieces are here and here. And we can see that if we bring this piece down to set up inserting this piece and pairing this up with the piece that we just brought down with the U2, we solve that bar. And so that if we bring that down, we have a solved face at the bottom, just like that. And then now onto the CLL recognition. So we can see we have a pie case, we have headlights, and then the other pair are pointing opposite of each other. And if we have it in this orientation with the headlights pointing to the left, bar on left, opposites on right. So then we'll just do the corresponding CLL algorithm for this. For U prime AUF. Here's the next scramble. So we can see if we're trying to look for pre-solved pieces, we can see again a blue-red bar with another piece attached to that bar, but this bar is not a solved bar, right? Because these pieces are not the same. But if we look at the remaining piece that we need to insert to make a layer, this blue piece is pointing up. So what we can do is move this so that when we bring the unsolved piece from this 3/4 of a layer up, it pairs up with the last piece we need to insert. And then we just move this, bring it all down, and there is our solved face. And then recognizing the CLL, we have an anti-Sune with the opposites horizontally, and then this piece matching this piece. And so we'll do the algorithm for this. I will note, using the same scramble, if we just ignore this blue 3/4 of a layer and just pretend it never existed. On orange, you can actually make a CLL layer, so a solved face at the bottom. If we note 3/4 of the layer are opposites around the cube, right? So this bar, opposite colors, this bar, opposite colors, and the remaining pieces here. So if we insert it like this, just a standard normal insert, we have opposites all around the cube. And another advanced algorithm set is called EG2, where you have a face like this with opposites all around the cube. But if you don't want to learn EG2, you can actually turn this into a solved face by doing R2, B2, R2, and voila, a solved face. So that's just another neat way on how you can make a solved face using that scenario. And then just for fun, we can also recognize this CLL case. So here we have an H case. We have one bar on top, and the bar is attached to one of the headlights. So in this case, we can do this algorithm. I have a couple more example solves using CLL in another video if you want to check that out. But otherwise, I hope this video was helpful. CLL can definitely get you sub 4 and even sub 3 with a lot of practice.